During the pandemic, the government imposed a lockdown that is assumed to only last a few weeks or months, but until now is still implemented. That is why millions of Filipinos are required to stay at home to prevent the spreading of the virus. Filipinos have found ways to cope being stuck at home. Many found new hobbies like cooking, playing musical instruments, video games, binge-watch TV series and movies, while some become plant enthusiasts whom we call plantitos and plantitas. These people buy potted plants to improve their houses with green sceneries and to also have something to take care of without the extra hassle of commitment. Soilid aims to help plantitos and plantitas to check their plants' health through the use of mobile applications that give a real-time update of the soil's moisture, ambient temperature of the plant's environment, and if it receives enough sunlight. With this project, it helps prolong the life of plants. So here's a live demonstration of our Soilid IoT app. So here we're trying to log in. As we can see here, we don't have any plants, so let's add one. Let's name it new plant. Add a birthday and its description. Hit add record. We go back, refresh for the new plant. Click on the new plant, and here we see our live updates for the new plant. So here we're going to add water to the soil. So you can see if there is a update for the soil moisture. Currently it's 600. And if we look at the app again, it goes down to 165, and your plant is well watered on the status. So we can see here that it's working correctly. And following is an explanation of our circuit used in the project. So here's an explanation of our circuit that we used in our IoT project. So here we can see we've used two microcontrollers. One is the Arduino Uno and the other is the Wemos T1. So let's start with the Arduino. So we have 5 volts and ground connected to the breadboard to power the 3 sensors that we have. So our first sensor is our DHT sensor, which handles the temperature and humidity. So we have 3 cables running through it, the VCC, the data, and the ground. So both VCC and ground are connected to their respective power, and data is connected to pin 5 of our Arduino Uno, a digital pin. The next sensor is the ambient light sensor. So this is an analog ambient sensor. It has 3 outputs, or inputs, I mean. So we have the ground, we have the VCC, and then we have an output of analog. So since we need an analog connection for that, we have used the port A0 of the Arduino, this blue cable, and both VCC and ground are connected to their respective power. And the last circuit that we are going to use for this project is the soil moisture sensor. So here we have 2 components. One is the driver circuit, which are connected to VCC and ground for this one, and we have the option of selecting either a digital output or an analog output. So we opt for the analog output, and that is connected to the A1 port of the Arduino. Then for the probes, we have 2 pins for each respective probe. So how this works is if we put this in the soil, it'll measure how resistant it is in ohms. So basically 1000 ohms, meaning that it's either super dry or not connected to any soil, and then anything lower is its moisture value. So it could have a moisture value of 0 theoretically. Then for our Wemos, it's only connected to the it's RX pin, so the pin 0 of the Wemos is connected to the pin 1 of the Arduino Uno, so that we can have a serial connection between these two microcontrollers, because we are going to use the Wemos to upload our sensor data straight to the database. And powering these two devices are USBs, so we are going to need our USB power bank. So I opted for just a generic USB power bank that has two USB inputs. So if we connect them, it powers up the whole circuit. So that's the explanation of the circuit. So this is the schematic for the circuit that we just made. This will serve as a guide if you want to recreate the circuit yourself.
Explain ko naman yung RTOS code namin. So bali, merong include Arduino pre-RTOS, include DHP test, bali para siya kay DHT sensor. And meron kaming define soil sensor A1, bali kaya meron nun kasi gumamit kami ng analog pin, which is si A1. Next naman is si task handle, bali ang ginagawa niya is gagawa ng handler para sa pagkuha ng sensor data ni soil sensor, ni DHT at light sensor. Tapos ito naman yung yung mga variables namin na ginamit, which is si DHT test, DHT para kay DHT, int light equals to 0 is para kay ambient light sensor, soil equals to 0 para kay soil sensor, yung float temp and humidity para naman sa DHT na sensor. Ito naman itong string sensor, bali array siya na may 4 na containers. Bali yung containers na yun is ginagamit pang initialize, and dito mapupunta yung mga sensor values na makukuha natin. Dito naman sa void setup, yung ginamit namin is nakaset siya sa 9600. Bali siya yung gagamitin pang run for serial monitor and pang check kung anong lalabas sa serial monitor. Then ito naman yung yung DHT setup naman is para sa DHT sensor, kasi gumamit kami ng ang ginamit kasi namin pang read is yung port 5 ni Arduino. Then ito naman yung RTOS code naman na si x-task create. Bali, maglalagay tayo ng method name niya, which is si sensor data. Then, pangalan ng task, which is si sensor task. Then, yung 300 is, yan yung size na i-allocate natin para sa task. And i-reserve natin para kay sensor data. And para naman sa void sensor, ipapasa dito yung yung array dito sa task na to. Then, ito yung 1. Siya naman yung priority, and then yung handler. Since wala kaming code sa void loop, gumawa kami ng static method. Bali nagre-receive siya ng PB parameters, and bali dito manggagaling yung yung x-task create na ginawa namin. Then ito naman yung while loop, kaya while 1 siya, so bali infinite loop siya. Bali syempre labas lang ng data. Ito yung itong first 2 lines ng code sa while loop, ang ginagawa niya is siya yung pangkuha ng array, which is tong string var, this for strings PB parameters. Then second naman is tong tong analog read naman. Bali, ang ginagawa niya, ang mangyayari dyan is ilalagay sa unang container. Then, bali siya yung index 0, which is itong nasa string sensor. Then, ito naman sunod is itong humidity and temperature naman, siya yung index 1 and 2. Then, ito namang soil, pang index 3. Tapos itong for loop naman is ginagamit if tama yung ina-output ni Arduino. Then ito namang bar is equals to curly braces. Bali siya yung pang clear ng array para sa next upload. Then yun, bali naka 3 seconds delay lang po.
This is our Wemos code for the final machine problem. These lines of codes are the two libraries being used in order for us to connect to HTTP client. Then we initialize a variable string data received, and then we initialize a variable for ambient, soil, humidity, temp. These lines of code are for the Wi-Fi setup connection, HTTP client HTTP1 specifically being used to connect to PHP. Inside void setup, serial.begin 9600 line of code allows us the usage of serial monitor. These lines of code's purpose is to verify if we are able to connect to the Wi-Fi. Inside a void loop, the serial.available greater than 0 is where the serial print of Arduino goes, which is connected using TX pin of Arduino and RX pin of the Wemos. The serial.read string until is where the Arduino sends the data sensor per line, then separates it per new line, since the ambient goes first, humidity, temp, soil, then they will be separated respectively. Data received.float code is to be able to read the string to their respective variables. This line of code is to check if the Wemos is connected to the internet. And these line of code sends the needed variables soil, temp, humidity, and light to the PHP file, which is also converted to string. This line of code is to add the header. This line of code runs HTTP requests, and this line of code is to get the response if it is sending or not.
For our MP, here is our database. For the database, we have 3 tables, which are live data, plant table, and user table. We go first discuss the elements in the plant table. For this table, we have the elements plant ID, username, plant name, birthday, and description. In this table, we set the plant ID as the primary key that has auto increment. The function of this auto increment is that every newly added plant will have its own unique ID. We also set the type into integer. It's 11 because I think it's the default. For the username, it's the foreign key for the user table. We set the type to varchar64 to have a unique set of username and also to widen the limit of the choices for the username. I mentioned it earlier that we set the username to foreign key to have access to the user table. We have the plant name, which is set to varchar64. Next is the birthday that has the type of date. And lastly, we have description that is set to varchar255 in order to have the full description of the plant. The next we will be tackling is the user table. Here in the user table, we have key fields, username, password, first name, last name, and middle initial. For the username, we set it to primary key that has the type of varchar64, and we set And after that, we have the password that is also set to varchar64. First name is set to varchar32. Also, the last name is set to varchar32 and the middle initial is varchar62. Last, we will tackle the live data. Here in the live data table, we have key fields moisture, temp, humidity, light, time. The first four key fields are set to float for the reason that we need to have the exact data of the elements for exact measurement. The time is set to timestamp. It has a default value of current underscore timestamp. It automatically puts the timestamp for each data entries. And I think that's all for this database, my PHP. Thank you.
Okay, so as previously stated by my groupmates, our machine problem is called Soilid. It monitors the plant's health through the soil's moisture, temperature and humidity, and as well as ambience. So as the developers used DHT sensor, DHT11 sensor to get the temperature and humidity of the area, as well as other sensors. We adapted the concept and code from our subject last term for this current machine problem. The Arduino and Wemos are connected through the RX and TX pins. So on the Arduino code, we used serial.begin to start the exchange of message with the serial monitor and used 9600 as the baud rate. Then we instantiated the DHT11 that is connected to the pin 5 of the Arduino. We used the data type float to get the temperature and humidity from the DHT11 sensor, which is then displayed in the serial monitor along with the soil moisture sensor data. Now, on the Wemos side of our code, we have lines of codes here for the connection to the internet. For the data received from the sensors will be sent to the database. Also, we use PHP for sending and getting data from the database. So we have PHP files for connecting to the database that has the host, user, password, and name of the database. Also, we have the basic functions, the register or add user, add record, which is they add plants, retrieve or get the information about the user plants and the user, update, search, and delete. All of the data retrieved from the database will then be displayed through our mobile application.
So here's our explanation of our Android Xamarin code for our Soilid IoT application. So here we have splash activity. This would only show the splash screen upon starting the application. So it would apply the theme that I've set in styles.xml. So here we have it here. And it's drawable, splash screen. Next is a login activity. So here we'll see the IP that we're gonna be using for our server. And mostly the code here is about logging in the user to the application. I have modified the code for the HTTP client because we used the previous code without asynchronous tasking, and it would just sometimes crash the app or just lag out. Upon researching on the internet, it is said that we need to use an asynchronous method or task when we want to run an HTTP client. So once I've done that, all all of our lagging issues and crashing issues have gone away. Though it is a challenge to actually implement asynchronous methods, such as adding click functions. It would also change how click functions actually work, because this is how we would normally assign a click function to a button. But if we want to do an asynchronous click, we would do this kind of method using an async name and then using the await keyword. And mostly we would just be using the PHP files that will be mentioned later. So after that, here we have the activity login. This is how it looks in the application. So you would see the username, the password, we're signing in, and then this is the register string. It doesn't render properly on the XML viewer, but on the application it would show a register and then an underscore. And then we have a hidden object here, which is the progress bar. If we click the sign in, it would show us a loading animation. So next is the main activity. So here we are going to be viewing the user's plants, list of plants. So we're going to be utilizing a list view. It was quite difficult to get the list view working without crashing. Upon reading tons of articles, it said that we need to be running on UI thread if we want to update the list and perform asynchronous tasks so that we don't, crash the app. So all that's good. And we also made a custom list adapter that would show a custom list row, which is this one. And then it would use that as a template for the lists that we have for the user. So here's the main XML. Here we'll see the list view be populated with the plants of the users. We also see here a edit button that would be for registering a new plant in this register plant activity. Let me pull up the UI. So let's register plant. So here's how we'll register a plant. This is we reused code for what we've done in a previous lab exercise, so we take advantage of that. So that's all good. Next is register user activities. Basically the same as the plant, but except for plants, it's for actual users of the app. So we just copy pasted some codes. And then for the main activity that we actually would like to implement is we've implemented is the plant activity. So let me get the plant activity. So here we can see it's a mix of linear layouts and relative layouts. So we can scroll this if your screen is small. And we have here the description and the status of the plant itself. So this UI would be updated every 3 seconds, if I'm not mistaken. And it would get the data from the database at that interval. So what we've done, we have a run on UI thread, and then it would await refresh data. And in this refresh data method that's asynchronous, we've made a timer that would run for 3 seconds. So we would run the HTTP client to get the initial values so that when we open this activity, it doesn't show us blank, but instead it shows us the first value that it gets from the database. And then we are going to put this code again on a timer, and it would refresh the view every time. And then here's a method for updating the health, so that it's not redundant too much, because it's a lot of if statements. And that's basically our application.